Let us discuss this particular question, and the question says, consider an expanding sphere of instantaneous radius r whose total mass remains constant. The expansion is such that the instantaneous density rho remains uniform throughout the volume. The rate of fractional change in density, that is given by 1 by rho into d rho by dt, is also given to be constant. The velocity v of any point on the expanding sphere is proportional to. Let us understand what we have to find. So we are having a sphere and its instantaneous radius, that means radius which is calculated at that instant of time, it is given as r, and the density of this is rho. However, it is also given that the mass remains constant, that means the mass is not changing, but whereas the density is changing because our volume is changing, because volume is given by 4 by 3 pi r cube, and it is expanding, so we can say that the radius is changing continuously, that means the volume is changing continuously. Density is given by mass by volume, so mass is constant, so volume is changing, that means our density is also changing. So what is exactly asking in this question? This question is asking us to find dr by dt, which we can also say as the velocity on the surface of the sphere. The rate of change of radius will give us the velocity on the surface of the sphere. To proceed in this question, let us we know very well that the mass of this object mass is given by mass of the sphere is given by density into volume, that is equal to density into 4 by 3 pi r cube. Now since we are going to find dr by dt, let me differentiate the both hand sides with respect to t. So that will give us dm by dt is equal to, this is the complete function. We can apply the product rule here. We can apply the product rule to get that. The first function is rho, that is going to be the constant. While writing the first term of the differentiation, rho is constant. Differentiating the second function, I get 4 by 3 pi out, which is constant. Then I get 3r square. Applying the chain rule, I can write again dr by dt plus the second term of the differentiation. For that we have to take this 4 by 3 pi r cube to be constant, that can be written as it is into d rho by dt. Now as it is given that the mass remains constant, the rate of change of mass with respect to time will equal to 0. On rearranging, we get rho into 4 by 3 pi into 3r square into dr by dt is equal to minus 4 by 3 pi r cube into d rho by dt. Now we can see very well that we can cancel 4 by 3 pi on both hand sides, and also here we have r square, here we have r square, r cube. So on the right hand side we are left with only one r. Now this rho we can take to the right hand side and we can write 1 by rho into d rho by dt. Let me put this in the bracket because there is something mentioned about this term in the question, and on the other side I will be left with 1 by 3 into 1 by r, because this r I have taken to this this side, and with that I have dr by dt. Now this also I am putting in a bracket because this is what we have to find. This we can call it as v. This is given constant in the question, so this is going to be constant. Let me call it as k. So k is equal to 1 by 3r into v. I can take, there is a minus sign also. I can take this 3r to the other hand side. I can write 3k into r, that is equal to minus v. From here we are getting that v is proportional to r, and the question was asking to find out the proportionality, the relation between v velocity, that is at any instant on the surface of the sphere, and radius r. Let us confirm this with the answers. Let us well, yes, it is r. Thank you for watching.